Hi everybody, my name is Julia and I'm an application engineer at Emlid. Today we're going to check what features we have in our software in Emlid Flow and Emlid Flow 360. We're going to check the features themselves, how you can use them, and in which workflows they're handy. We're going to work with, as I mentioned, Emlid Flow and Emlid Flow 360. Emlid Flow 360 is our cloud-based app. You can see it on the left side of the screen now. It's needed to get prepared for your field work, to import the data, and to work with the results. So once the field work is done, you can export the files from here and save them directly to a laptop. We're also going to use our mobile app, of course, Emlid Flow. It's available for Android and iOS. The app can be used, it covers basically two main tasks. Here, the first one is the configuration of the receiver. When you configure it as a base or the rover, configure its GNSS settings, use it to record raw data logs for PPK. And the second main, big task is, of course, data collection. And today we're gonna focus specifically on it. So we're gonna mostly collect the data again, check the features that we have for it, and use cases, of course. How the apps are connected. For that, we have our Emlid account. So now I'm logged into my account in both apps. And yes, once I collect the data or import the data in one of the apps, it gets synced and appears in another one too. So, okay, let's begin, I think. And we will begin in Emlid Flow 360. So let's create a new project here. We can call it demo. And here we come to the first feature we're going to discuss. So here we're going to use a code library. Why codes are needed and what this is all about. Codes are helpful for topographic surveys when you want to define and specify what type of object you're collecting, whether it's a fence or building corner or pavement, for example. Default options for code libraries, just two. There are two of them. First one is point lines. So here you see only point and line. Well, this one is not about topographic surveys. It's not about adding some additional information. It's just about distinguishing whether you collect a point or a line. And we also have a default option with Emlid library. It contains 100 most popular codes for topographic surveys. So you can also choose it, and we're going to use it today in our project. But let me also talk about one more option that we have here. You can see custom, it's a spoiler. So if you are used to working with some custom codes that you just are convenient, handy for your project, you can add a custom code library here. You just add a name for it. Okay, let me name it my library. And after you do that, you have an option to import a CSV file with the codes you want to use. Here we also have an example, so you can see in what format the CSV file should be to have it all displayed properly. But again, for today, let's just use Emlid library. And let's proceed. Next option going to be choosing a coordinate system, and here we also have options. The first one is just to use a coordinate system from our registry. So here you can use either the name of the coordinate system, the name of your country, or UPSD codes to find the right one. Our prepared project for today is for Switzerland. So I'm gonna just, write it. My project is just in the UTM projection, so I just choose it. And here I can choose the height I wanna work with. Let's apply it. Let's talk about other options that we have here. So apart from choosing the coordinate system from the registry, you can also use global option. This one is about working with the geographic coordinates only. So when you don't have any transformation, you just work with the latitude, longitude, and ellipsoidal height. No projections applied, no transformation, nothing. And the last option here is using a custom coordinate system. So what is available here? Technically, it covers two workflows. And yes, the first one is when you work with some local coordinate system and you know its parameters of transformation. So then you can just specify them here, just add all the parameters, save this coordinate system, and it will be stored in your account. So you'll be able to use it for all the future projects. Another option may be to work with localization, and we're going to try it in the field soon. But this one, let me just add a short note on this. This one is about the case when you don't know the parameters of this coordinate system, but you still have a local one, and you have some points with known coordinates in this coordinate system. So you define the coordinate system by the points in it. We're gonna try it soon, so yes. Just to note that once you also do localization, the coordinate system, the parameters of it will be stored here. And again, you will be able to apply it to the new projects too. For today, yeah, we chose the coordinate system from our registry, so we're good to proceed. What else we have here? The linear units. Here you can choose feet if you'd like to work with them. We're gonna stick to meters today. And yeah, there's also setting for angles, so you can display them either in decimal degrees or in degrees, minutes, and seconds. I use degrees, minutes, seconds. If you want to adjust it, just do this in the preference. It will be applied to all the projects you have. So let's go on. And yeah, now we have our new project. For now, it's empty. We didn't add anything here yet, but let's fix it now. So to import the data to the project, you just hit import. And yes, you choose the format of the file you want to import. We support CSV, DXF, shapefile, and KML. My prepared file is in CSV, so I'm gonna use it. Yep, and let's open it. So now you can see the data, yes, is loaded. And yeah, you can also see it actually in the Emlid Flow now. Okay, we have a different background. We're gonna talk about the background soon, but yes, once I loaded the data in Emlid Flow 360, it also appears in Emlid Flow, and technically I'd say that I'm already good to go and proceed with surveying. But let's check a few more features, a few more options we can do on this preparation stage. So one more thing we're gonna work today with is surface, so let's also import it. We just go to import, choose a surface file. We support surfaces in LATXML format. Choose the surface and voila. Now we have our surface. I bet it's also already synced to Emlid Flow, but we also need to activate it manually here. Yeah, now we're good. Okay. Yes. What else can we do on the preparation stage? If needed, you can add points manually. So for add point, you can choose a code you want to use for it. For example, let it be anchor. And yes, here specify the coordinates of this known point that you have. Local or global ones, it's up to you, the ones you have. Yeah. One more thing you can do is to add a line or polygon. So just draw some geometry. For example, I want to connect these 2 points and draw a line. Yeah, I just choose them and save. Oh, no, let's check it this way. So let's choose 3 points. And here you see that when you choose 3 points, you can either leave it as a line or make it closed line. So make it a polygon here. This is how I save it. And yeah, if needed, all the data can be adjusted before I start to work. Yeah, you can see it's all already in Emlid Flow, already good for measurements. If I have the opposite goal, so I want to remove some geometry, I just hit it here, added line. Now I need to choose the line. And yes, when I delete it, I have 2 options: to keep point or delete everything. So deleting everything will remove the polygon completely. Keep points will allow me to just save the points themselves, just remove this polygon here. Okay, let's check one more thing and we will go to the field. It's layers. So by default, overall, you usually have just this regular map. So this one is not accurate. It's just approximate map, but it can help you navigate. So it can help you understand what happens around you, maybe convenient. Satellite map is sometimes a bit more detailed, so you can also switch to it and work with the satellite map. You can see that it can be configured both in Emlid Flow 360 and Emlid Flow to your convenience. But both these layers are only approximate. If you want to work with the more accurate data, you can add a WMS layer. So here I'm just gonna use the previously added one, but overall to work with the WMS layer, you need to have a link to the WMS service. And then once you access it, you can choose the right layer, the one you wanna work with. Division cover. Yeah, just the one layer I found that can be used. let's choose it. Okay, for example, this one. Yeah, once it's added, you can also apply it to a project. And, oh yeah, I saw it even faster in Emlid Flow than here. Okay, by default, it's not much fun. Yeah, and this one is a layer with different, like segments for Switzerland. You can configure it for the layer here. So choose the opacity, how transparent the layer should be for you. Yeah, I can keep it like this. But overall, of course, working with the WMS layers, it's not only about this kind of map. So it may be any information you want to display in the background. It may be utilities map. It may be, I don't know, any additional drawing. It may be orthophoto, for example, from your previous like drone flight, for example, drone mission. And yes, orthophotos can be just converted to WMS layer. And yeah, then you just use the link to add it here. Okay, this one, yeah, let's just disable it for now. And let's move to the field. Okay, and let's check one more feature before moving to the field. Okay, two features then. The first one is that you can adjust the coordinate system of your project if needed. So for example, if you by accident chose a wrong UTM zone, you can change it here and all the points will be recalculated to a proper UTM zone. And one more feature I wanted to show you is NTRIP profiles. So here in the profile settings, technical, I think we discussed everything already. Coordinate systems that you've added manually, map layers, WMS layers that we work with, code libraries, and yeah, finally, NTRIP profiles. So NTRIP profiles are needed for NTRIP connection. For connection to get corrections from the NTRIP service, you need to use credentials. And yes, it may be really convenient to add them here directly in Emlid Flow 360. You perhaps can copy and paste it. I have credentials for our Emlid cluster that we can use. Okay, let me call it just NTRIP. It's gonna be cluster emlid.com. And the password. Yeah, I also need to choose a mount point. Okay, let me choose this one and then I can save it. Once I've saved it in my NTRIP profiles in my account, they also appear here on the phone. And yes, now I can use it for my NTRIP connection to get corrections, to get a fix. And yeah, it's just, I'd say, simpler this way with Emlid Flow 360. But now let's finally move to the field. For that, I'm gonna use the phone I have here. I'm using a demo mode here. So it's the unit has a fixed solution, even though, well, we are here because it's virtual receiver. It's really good for demo, so that I don't need to go outdoors and record it all there. Yes, what we're gonna check first. First, we're gonna check two features, which are technically still on the preparation stage. It's base shift and localization. A few words about the base shift. So base shift is needed when it's not really convenient for you to place the base on the point with the coordinates you know. So you want to place it in some different location. For example, you have a point which is located close to the tree, so the sky view there is still good, but it's not really great. So it's not perfect for the base placement. In this case, you can place the base in the area with better environmental conditions, and this point just measure with your rover connected to this place base. So let's look through the steps, and let me check. Yeah, the project should be here. Yeah, let's say we are working here. So what we have here, you see 2 points, they're prepared for base shift. We have a known position of the benchmark. So it's the benchmark with known coordinates. And yeah, let's say that the sky view there is slightly obstructed. So instead of that, I place my base in a good location and I average single its position. I connect my rover to it and then go and measure this point. As a result, I get the point that is different, like from the point with known coordinates, because my base was placed in single. So what I do next, I do base shift. To apply base shift, we just go to this window for our project and choose base shift. Here we will need to choose the measured point. So it's our measurement with our rover of the point with known coordinates. And known point is going to be loaded coordinates of this benchmark we can use for the reference here. Now we have calculated shift, and now we apply to the project. So now all the data that are going to be collected after a base shift is applied will be shifted, and yes, it will allow us keep the accuracy to centimeters, so have it all absolutely accurate, have absolute accuracy. Yeah, even though our base is placed in the location with not known position. Please be careful that base shift is not moving your previously collected data, so it will only affect all the future measurements. One more feature we're going to check. Yeah, let's disable base shift now. One more feature we're going to check is localization. And as I mentioned a bit earlier, localization is helpful when you want to work with some arbitrary coordinate system and you don't have parameters of it. So you just have some points with known coordinates in this coordinate system. It may be, for example, the coordinate system of your construction site. So how to do localization? For that, you need to, again, place your base, connect your rover to the base, and measure the points with the coordinates, the points for which you know the coordinates in this coordinate system you'd like to work with. In my case, I have 3 measured points. And what I need to do now is to create pairs. I already have imported the points with known coordinates here. We go again to the project screen, choose project localization, and here add pairs of control points. So it's like points in the coordinate system we want to enter, we want to work with. Here it's gonna be this one, and measured points. I named them accordingly so that not to get confused. We have 62. Oh, one more pair. And it's going to be 67. Here today I use just 3 points, again, to shorten our demo. But overall, we recommend to use 5 points, or maybe a bit more, 5 to 10. Here, once you've added the points, added the pairs of them, you can see the residuals for it. You can also choose, remove some of the parameters, remove them from the calculations. You will also see estimated accuracy for the whole localization. You can preview the results, the calculated parameters, and you can apply it. Let's do so. So localization actually moves everything that you have in the project accordingly. So recalculates all the points, and you can also save it, as I mentioned before. Let's just name it localization. Let's do it like this. Now this coordinate system will also be stored in my account, and I can use it for my future projects as well. And here now you can see that the drawing that I had previously moved is here, and the whole project got recalculated. Okay, that's it with the localization. And let's move to the project we've prepared to check more features for data collection. So we will start with this simple data collection. When you want to collect a point, you just tap on plus. Here you can check, right here. I see now. You can check the height of the rover. Just make sure that it's correct. If needed, adjust it. For me, it's 1.8 meters. Here you also see the precision values and the coordinates that you have currently for your rover. To collect the point, just choose the right code. Let's say it's anchor, and tap save. So now we have the point collected. Let's check the settings that we have here. So the first one is just option to collect the points only when you have a fixed solution. I really recommend you using it. It'll help you to, again, make sure that all the data collected with a fix. So here you also have precision limit. Precision limit can be used, you can specify here the tolerance for your point collection. So for example, here I can specify it for 5 centimeters. Save it, and now if I have the precision values higher than 5 centimeters, I just won't be able to collect the data. So the app will wait till the values actually get within this tolerance. Let's check what else we have here. So now the collect mode is set as instant. You can see it here, which means I just hit the save button and the data is collected. We also have averaging. With it, during the point collection, you will see timer for a specified time. So it may be a recommended option just to average the position for a few seconds. And we also have an auto collection option here. Good. So we checked how to collect the points. Let's also check how to stake them out. So stakeout is helpful when you know the coordinates of the point and you need to find it where it's actually located on Earth. So for that, you just choose the point you want to work with and hit stakeout. And that's what you're gonna see. So you will see the distance to the point you're searching for, you're looking for in on Earth. Yes, you're staking out. There are two modes for stakeout here. First one allows you to see as now the north, east, and fill or cut values. But you can also hit this button. It's this one. And yes, switch to the mode for staking out by direction, where you see the distance, again, cut and fill values, and azimuth. So yeah. It can also be used for stakeout. One more option that we have here and that you can see is measuring in stakeout. When is it convenient? It's convenient when you do an as-built survey. So for example, you have a project and you need to see how the final result matches the project. So you just start staking out the project point from the project and collect it when you get its actual position. Then you do this measurement in stakeout mode. Okay, we set the timer, so let's erase it for a few seconds. And yeah, as a result, you get this staked out point. Let me move a bit. Yeah, you will see this flag so that this point is staked out. When you check the details for this point, you will also see, apart from its coordinates, of course, the deltas. So how this position is located in comparison to the original point we were staking out. Okay, good. I think we're good with the points, and now we can proceed with the lines. Okay, so we've checked how to work with the point. Now let's proceed with the line. So to work with the line, I need to choose the code. Okay, yeah, it was building. Let's choose a bridge, for example. And yeah, well, the process will be really similar to the point collection. Let's remove the timer though. Yeah. Okay, so I just go and collect the points, the vertices from my line. And yeah, get a line here. If I want to start a new line, I just click here and well, yeah, now I can proceed with a new line. Yeah, here you can also see an option to collect from the other side if you'd like to, or yes, for lines, let's collect one more point here. I can also close it and make it a polygon. This is it about the line collection. Let's also check the stakeout for line. So to stake out the line, it's also similar to the point stakeout. You just choose the line. You can choose it by tapping on the screen or from the list of objects. Just choose it and it's stakeout. But the options for stakeout here will be a little bit different. So first of all, you can see there are two modes, two line and a long line. So two line stakeout is really similar to the point stakeout. It just helps you to find the line in space where it is. Here you will see, yeah, the values. Okay, in my case now it's northwest, but of course it can be southeast too. And cut fill values. If I switch to a long line mode, here I'll see a bit more information with the different parameters of the line. So you can see the offset. Offset is this length of the perpendicular to the line or its extended version. So you can see, yeah, if I move here, the line is just extended and I still see this offset to it. Or I can get closer and yeah, the offset will also be fewer, but it will be less. Okay, and the values you can see here is the distances to the beginning or to the end of the line, so to A or to B, you can switch between them here in the upper part of the screen. And this one, this value is the measurement along the line. So just like you see this blue part, the line itself. You can also here, like it's clickable, so you can switch between different segments of the line and work with them separately here. And again, just monitor the offset, check the distance to the beginning to the end if needed. That was the line stakeout. Let's check just a few more features and proceed with the surfaces. So what we also have here, the features, it's inverse and traverse. You can find them here. When and why they need it, how to work with them. Inverse helps you to check the parameters of the geometry when it already exists. For example, I want to check, let me move, I think to, here. I want to check the distance from this point to this line. So I just choose them here and the data, the information about it is here. So the direction, the slope distance, height difference, all specified. If I choose more than 2 points, I choose, for example, one more, also this one. You can see that I will see not only the information about the distance, not only the perimeter here, but also there. Oh, no, it's more fair to say you see here separately information about the line itself, but it's also closed. And app automatically shows you information about the area and the perimeter as if it was a polygon. Here you can also switch between different segments of the line and check information for them separately. Okay. One more feature that we have here is a traverse, and traverse at some point is opposite to inverse. So traverse is about creating new geometry when you know its parameters. So for example, I want to draw a square from this point. So I choose the start point, then I choose the distance. Let's say I want my square to be with 5 meters side. Then I choose the direction. Let's say I want one of these sides go directly to the north, and height difference, let's say it's going to be 1 meter. Here you will see overall the preview for it, and you can save it here. Choose a code for it. The name, and it's saved now. So now I have a new point, and I can proceed with the traverse actually from it. So to build my square, this time it's gonna be, didn't switch to it. This time the direction gonna be 90, and let's say I want actually to have the height difference negative. So let's save it. The code again, let's call it anchor. Save. Okay, by default, no, I think I'll need to change it. Let's add one more vertical here. Okay, it's gonna be 180. Again, 1 meter, done. Save it. And let's check what we have in the result. Here's our square. Let's quickly use inverse to check the area of it, for example. All good. 25 square meters. Okay. This feature is available in Emlid Flow, but it's also available in Emlid Flow 360. So of course, you can work with it there as well after field work. Now I think we've checked everything in the field, and we can get back to the office to check how we can export our data. So now let's imagine we get back to the office, again, open our Emlid Flow 360. You can see that all the things we've done in Emlid Flow in our account are synced. So you can see the square that we've built here. All the data, all the measurements are here. To export them, you just hit export. Then you need to choose the format for the export files. So again, we support the formats CSV, DXF, KML, shapefile. For CSV, you can actually customize the file, choose whether you want to keep header or not, what you want to use for a separator, choose what columns to export, and for the columns you want to use, in what order you want to keep them. Let's just save it and export. What else? The stakeout reports. So today we also checked working with collection of the point in stakeout mode. Remember when we checked the deltas for the point? So here you can also generate a stakeout report where you will keep all the measured points, staked out points, and the deltas between them. We've checked 2 collection modes directly in the app using the demo mode on the phone in Emlid Flow. Let's check also autocollection feature, but for that, it's a little bit tricky with the demo mode because you need to move. So let's just check it on the video. So here you can see that we access the same menu, choose auto collection, choose the mode here. You can use it by time or by distance. Specify the interval, here it's 1 meter. And now we start moving. So what happens here is every time you reach 1 meter from the previously collected point, a new point is collected. You can also see this progress of the data collection, like how close you are to 1 meter distance now. And well, this is what it looked like. Now let's also check it for the time. So here you can choose the time interval. For example, we will use 10 seconds interval. And yes, let's choose a line. Lines can also be collected this way. And again, start the data collection. So once we start moving, the timer starts. And now every time we reach 10 seconds from the previously collected point, again, new point is collected. So you're gonna keep collecting the data this way till you stop it here. Okay, let's wait for this one more point. Okay, this is how auto collection works. To work with the surface, now let's also move to our videos. Maybe a bit easier so that you can see different statuses for surfaces. Yeah, the first thing is just to make the surface visible, available, activated in the app. Now we choose the surface and hit stakeout. What you can see, yeah, the first status you can see it's out of surface. So when the rover is located not in the area covered by surface, you will see this. Once you get to the area covered by surface, you will see cut or fill value. Yeah, you can see both of them. When you get to the surface, so it's like you're on the surface, this value becomes green. So that means you're within the tolerance, you're on the surface. Yeah, this one is mostly practical for earthwork. So when you have a construction material and you need for every point to understand whether you need to cut and fill, well, cut and fill values are here. And now let's check one more video. So we checked how you can work directly with the surface in the app, how to stake it out and check cut and fill values. But you can also work with the points and lines on the surface. So for that, the points and lines which just again are located in the area covered by the surface, you just choose them. Yeah, and hit stakeout. So now you will see not only the values you saw in the regular stakeout, but cut and fill values as if this line or point was located on the surface. And again, you can proceed with the regular stakeout. And that's it for today. Thank you very much for watching it. Today we covered most of the features that we have for data collection, both in Emlid Flow mobile app and Emlid Flow 360 cloud-based app. You can try yourself everything. For that, just follow the link we leave in the description to start a trial or subscribe and get the app, of course. Thank you once again, and see you next time.